if we have a generic right triangle and we label an angle theta just for fun, because we label angles using Greek letters. It's just what they do. Talk about the Greek geometers. You guys know about sine. Sine of theta is going to be equal to, okay? And it compares the sides to that angle. Okay? The things you need to pay particular attention to is you need to know that there is a hypotenuse of a right triangle. The hypotenuse is always directly across from the right angle, right? If we're talking about an angle theta right here, what's this side right there that I'm pointing to? What is that side? What do we name that? We name that the opposite, right? The one that's across from. The opposite is the one across from the angle. And then this one right here, what is that one? Adjacent. The adjacent side is the one that's connected to the angle that is not the hypotenuse. When you label this, when you're doing problems, I suggest you identify where the hypotenuse is first, and then derive the other spots. Which one's the opposite, which one's the adjacent from that. Okay? But the hypotenuse is pretty clear because it's across from the right angle. And if you're having trouble differentiating which one is the hypotenuse, we got to make sure you can do that. So sine of theta in this particular triangle is defined as what? Do you guys remember? The opposite over hypotenuse. Cosine of theta is, we abbreviated cos. Cosine of theta is adjacent over hypotenuse. And then tangent of theta is opposite over adjacent. Now, you guys might have talked about an ancient, an old Native American called Sohcahtoa, right? Sohcahtoa, okay, which is kind of, what is that, an acronym? Is that the right word? An acronym to base these ratios off of, okay? The sine of the angle is the opposite over hypotenuse. Cosine of the angle is the adjacent over the hypotenuse, and the tangent of the angle is the opposite over the adjacent. Does that make sense? Okay. If you guys are familiar with this this myth of this famous Native American, that Native American has a cousin named Sohcahtoa. Okay. They're kind of opposites of each other. They're like, one likes I don't know. One likes the number 2, the other likes the number 1/2. Okay, they're kind of they like reciprocal numbers from each other. That helps us get the reciprocal trig functions. There's a whole other set. There's 3 more trig functions that we call the reciprocal trig functions. There is one called cosecant, which is abbreviated CSC, and cosecant is defined as the reciprocal of sine. So it's actually the hypotenuse over the opposite. Okay? Cosine, the reciprocal of cosine is called secant. Oops, I should spell it out. Just the secant, which is abbreviated SEC. So secant of theta would then be the reciprocal of that hypotenuse over the adjacent. Okay, that's why Sohcahtoa and Sohcahtoa, they like reciprocal numbers. One likes 2, the other likes 1/2, right? Because they're reciprocals of each other. Then you have cotangent, which is abbreviated COT theta, which is opposite over adjacent. And again, to spell out Sohcahtoa's name, it's Sohcahtoa. Sohcahtoa. Okay. Oh, yeah.
For cotangent and tangent, they're the same.
Yes. match up. And notice how I wrote these guys. The reciprocals are paired up across from each other. And I would highly recommend, as you're trying to memorize all of this, you match those together in your head. Okay? I would almost understand that when we're talking about cosecant, you match that right with sine. Yeah.
The tangent and cotangent are the same.
Oh, did I write it wrong? I wrote it wrong. Sorry. Sorry about that. Thanks, Matt. Did he? I didn't hear him. Sorry. Oops. Okay? Reciprocals of each other. From this, all the other stuff that we're actually doing in this chapter is going to be a derivative of those models, of those functions. Okay? So, right now, I'm going to propose a problem for you, and I want you to just work through that problem. I'm going to give you some information, but not all of the information that you need. Okay, I'm only going to give you some because I want you to use the skills that you learned last chapter, where you were given information, and you were also given a model to use for that information. And you solved some things, you answered questions based on that information. And that's what we're going to do right now. So I'm going to give you a question. I'm going to give you a setup, and I'm going to set you loose for a few minutes to try to use that setup and that information I give you based off of these models and using these models. Okay? That make sense? I want you to think. I want you to problem solve through it. I think you have all the skills. If I give you this and things you've learned previously in previous classes, you'll be in good shape to do this. Okay? So I'm going to pose a question for you, and then we'll get going.